Jacob Nance is with Vanderbilt, and he is going to share with us on DevOps. And DevOps, and I'm just going to, I'll let Jacob introduce himself, but I will say that he's a Murray State grad. But beyond that, I wanted Jacob to share with us today because DevOps is a term that is being used more and more and more by industry across the country and specifically within our region. And it's not something that it's just for the networking guys, and it's not just for the programming guys or folks. It is for everybody across the enterprise to understand what DevOps is. And it's not just a large organization issue. It is large, it's small, it's for the programming team, it's for the networking team, it's for the security team, it's for everybody to understand. And so what we asked Jacob to do is to join us today and just give us perspective of DevOps from a practitioner's perspective. And that's exactly what Jacob is. He has done that now with multiple organizations and is an expert in this area, and asked if he would come back virtually and share some of his knowledge with us. So with that, Jacob, I will let you share your screen and you can take over from here. Thank you very much for joining us today.
Thank you. I am trying to share now, but I think I'm having a technical issue, unfortunately. Looks like I need to allow system preferences. I'm sorry. Give me 1 second.
Okay, that's all right. While Jacob's doing that, let me reiterate a couple of things for the folks that are watching. As Jacob goes through his presentation, please make sure that you type in the comment section underneath the video any questions that you have that come to your mind. That if you want to ask a question, please feel free to do that. Again, just like with our previous speakers, as Jacob goes through his presentation, there's going to be about a 20 or 30-second delay. So sometimes it's hard in real time to answer a question. But if not, then I will make sure that I'll collect those questions from all of our different feeds and share those at the end so that you can get those questions answered. Also want to say that thanks to our co-host, CFSB. I know that CFSB has been sharing different things on different feeds. So I want to say thanks to them for helping out with the social media and the push. And as always, thanks to our sponsor, AT&T, for what they do. So with that, I see your screen. So I think, Jacob, you're good to go, and I'll turn it back over to you.
Okay, thanks. Like it was said, I graduated from Murray State University in 2008. At the time, a degree called Telecommunication Systems Management, mostly networking and infrastructure focused. I just want to briefly go over my employment history because this is going to kind of be relative to the story of DevOps and where the industry itself, IT as a whole, has been headed. So while I was a college student, I interned for Caterpillar Financial in Nashville. Great internship. They ended up offering me a job, and I came to work on their network team straight out of college. Caterpillar is the bulldozing company, a very large enterprise. Their financial wing is also very large. And so I started working in their IT organization, and I worked on the network team. And at the time, IT itself was very large, very enterprisey, and very segmented. There was a network team, there was a telephone team, there's some server teams, there's the security guys, then there's the developers and different development teams. It was all very much like fragmented, and everyone was doing their own thing. And then we had 200 employees in the IT department trying to work together to accomplish the business goals. I stayed with Caterpillar for about 9 years, ended up working on their network team. I deployed voice over IP, the Cisco telephone system. I worked on their Windows and Linux server team. And then I ended up on a team called App Hosting for a while. And then I got an opportunity to work for Lifeway. So I switched employers and started working for Lifeway IT, also in Nashville. And they were kind of more enterprisey, but a little bit different. Instead of having different teams for network and server and security and data center, all those guys reported to the same manager, and there were less of us. And you think that meant that we had a smaller footprint, but that wasn't the case either. Lifeway just had a smaller IT shop doing a similar workload of infrastructure. I went from, just an example, the Caterpillar Linux team had 4 people on it. And when I became the senior Linux engineer for Lifeway, I was kind of overseeing the Linux team at the time, but it was just me and another guy. It was just 2 of us instead of 4, like it was a Caterpillar. And then a funny thing happened when I worked for Lifeway. The first year, it was a very traditional enterprise server management role. But then we kind of absorbed this other team that was within the organization called the platforms team. And this platforms team was this group of infrastructure engineers that weren't reporting to the infrastructure department. The app teams basically had created their own infrastructure team to deploy their own infrastructure, so they didn't have to deal with the other infrastructure team. In IT, this is kind of called like shadow IT, where people basically just get fed up with the red tape and then they just hire a couple of people to do it themselves under the same manager. Well, my infrastructure team absorbed the platform engineer team. So we took on that responsibility that they had, and they took on some of our responsibility. But they were doing things completely different than what we were doing. We were running traditional like VMware. We had a data center, and they were doing everything in AWS. Everything was migrating towards serverless. They had already been on containers and were ready to go to serverless. And the type of work they were doing was drastically different. They weren't logging into servers or doing deploys or troubleshooting issues. They were massively building out new infrastructure every day and tearing down old ones every day. And they had 3 people, and we had an infrastructure team of 12, and they were managing what was essentially a larger data center than what we had on-prem at the time. So by absorbing that 3-man team, we actually took on a data center footprint. It was in AWS, but it was doubling what our current data center footprint was. And then in the middle of a pandemic earlier this year, I started working for Vanderbilt IT as a cloud engineer. I'll get into that now. So my official title is a senior systems engineer. I'm a member of a 3-man team, so there's 2 other guys working on the infrastructure team for Vanderbilt. And we handle all of the infrastructure resources for Vanderbilt Medical Research. So most of our customers are applications that manage research and propagate data, and other people want to access that data for research reasons. But there's only 3 infrastructure folks doing this. We have a side security team that handles a lot of our auditing requirements and kind of polices that, but we're the only 3 people in charge of network, load balancers, maintaining servers, deploying applications, runtime, monitoring, all that. And if this was 10 years ago, there wouldn't be 3 of us. There would be 12 or 20 people doing this sort of job. And that's why I'm here to talk to you today, is about DevOps. And that DevOps is the reason why there's only 3 of us right now instead of 12. I love this slide. So DevOps is a bit of a marketing term these days. You can see it all over the place with products trying to sell themselves as this is how you do DevOps, or buy our tool and we'll tell you how to do DevOps, or buy this book and this book explains what DevOps is and why it's important. It does mean a lot of things to a lot of different people. In some cases, it can be a workflow. In some cases, it's just tooling, making sure you're using tools that are like DevOps compliant. And for a lot of people, it's a mentality or it's a specific mindset. But for me, it's a little bit of a buzzword in that it's used just all over the place all the time to basically describe what I would say being better at your job. Like DevOps is about taking problems and solving them quickly and fast and moving on to the next thing, and not basically getting stuck in a loop of doing the same thing over and over again forever. And technology is fast changing, so there's lots of new tools that are developed constantly to help us solve existing and earlier problems. And sometimes the tools promise to solve future problems, but don't ever look for that. Okay, so I'm gonna break down Dev into the 2 sections, Dev and Ops, Dev being development and Ops being operations. This is a classic fight between 2 sides of IT, the developers and the infrastructure guys. And then security's in the middle, telling both of them what to do the whole time. But we're going to jump, I'll get to that in a minute. Let's jump into development. So developers have one job. They are to make the thing, whatever the thing is, whatever the business requirement is, a button, an app, a new field. They need to make a new survey. They need to program the website to send an email out to people. Whatever that business requirement is, a developer's job is to take that requirement, use their skills and their experience and whatever tools they deem appropriate to make the thing. And that thing is called an artifact in the industry. So developers make artifacts. Artifacts can be a lot of different things, which is why it's called a generic term like artifact. So just keep this in mind that developers aren't worried so much about other things besides making the artifact. They have a business requirement. They need the website to do this now. They need a new level designed for their game. They need a new DLC pack developed. Like, the developers are focused on making that thing. Operations guys are not focused on making the thing. Operations guys are different than developers in that their job is to make sure whatever the developers make, they can run. Whatever the developers create, because that's what the business demands, the operations guys are in charge of making sure it actually works. And I don't mean the making sure the button does what it's supposed to do. I mean making sure the button is available whenever everyone logs into the website. So this entails basically the entire mindset of infrastructure. You've got servers, software, networking, hardware, configuration. And then you also have patching and just overall taking care of your infrastructure, keeping it up to date, security, patching, auditing. And then there's new requirements. Red Hat may come out with a new version, or there may be a new package or a new technology that the developers want to use on the servers, or containerless or serverless architecture. Operations guys are meant to basically control that ecosystem and make sure the artifact that the developers create will run on it. So this ends up creating a split in skill set, where you have developers who are making their product, their artifact, how they want to make it. They're using the tools that they're familiar with and that they like, the languages that they want to use. They're packaging them up the way they want to, and they're using workflows that they like. And their mindset is that they need to hand over that artifact and say, here's my code. It needs 18 gigs of memory and 4 CPU to run. It needs a giant database. It needs 17 databases. It needs 2 terabytes of storage. Like, whatever the requirements are, their job is to hand over their code and tell operations, it needs this much stuff to work. But that's not the end of the development lifecycle. They also need to be able to add features and bugs when new releases are needed, and they are always needed. And I can't stress this enough. This is always an issue with new products, is that there's always this mindset within management that we can just create the new project, create it, and then move on to something else. But the truth is, there's always features and bug fixes that are going to happen. And how well you deploy DevOps determines how easy it is to deploy those features in the future. And then perhaps the most important thing here is, like, developers need to keep making new artifacts as fast as possible. They can't just make the new button or make the new DLC content and then they're done. Like, they didn't do their job for the year. Once that's done, they need to be able to turn around and make another one as fast as possible. And I say as fast as possible because that's what business generally demands, is that we need to iterate quickly. We need to make changes. We need to make sure those changes are good, and then we need to make more changes. And that's been a bit of a shift for like the past 15 years in the industry, is that people went from like creating these monolithic giant packages to, we're going to do smaller changes as quickly as possible. So that's developers and their skill sets. Operation folks have different requirements and different ideas of how to be successful. They want to provide identical dev, test, and prod environments. This is critical. If a developer is testing their new code, their new DLC package in test, and then they deploy it to prod and it doesn't work as well because prod has different security setups, maybe more firewalls or more restrictions or more lockdowns, and it doesn't work. And now your whole system is not working for 2 days because everyone's rushing to figure out what's going on and why it's broke. That's a huge mistake. And it's because dev, test, and prod environments aren't identical. So it's very critical that as an operations person, we want to make sure all the environments we create are identical. We also need to be able to take artifacts and run with the requirements. The developers need to hand me an artifact, hand me the list of requirements, and I shouldn't have to ask them a ton of questions. I don't need to know what they're doing with it, how it's working. They should just be able to quickly hand me the thing, and then I deploy it. And when I deploy it, it needs to stay up. You can't just run something and then be like, okay, yeah, it's up and running. Like, yes, problem solved. I've got something up and running. But redundancy is very critical in almost all applications, and that you want to ensure that when there is an issue, because there will always be an issue, you have a redundant system that is going to be fault tolerant. It can handle a server going down. Netflix is a bit famous for this, for developing what they called a chaos monkey. So they created, they understood the problem of making sure uptime is important whenever a disaster happens, but they didn't want to wait for a disaster to happen to make sure they were going to have good uptime. So they created a chaos monkey application that basically went throughout their data center, their environments, and just started turning things off. It would turn off a server, and hopefully if that broke something, then they knew that someone didn't design their systems to be redundant. They would kill network switches or routers or block subnets. And that would alert them like there is a single point of failure. Someone didn't make a fully redundant system, and that's bad, and now we need to fix it. A lot of companies don't have full faith in their environments to run Chaos Monkey. They don't want to turn something on that's going to start turning off some of their stuff every now and then. And I totally get that. But Netflix's approach worked. How often is Netflix down? I've been a customer forever. I mean, Google.com has been down and Netflix hasn't been down. So it works. And it kind of makes a standout feature of Netflix. So outside of uptime and deploying the code that developers make, operations also need to do ongoing, constant system security and compliance changes. There are always new patches that need to be updated. There are always new versions of packages. Sometimes the developers don't make them. They depend on Java. You need to update the version of Java running on the server. And you just have to be prepared to make those changes. Or else you're going to fall out of compliant, and LBMC is going to tell you that you're going to fail your audit and you're not going to be able to take credit card payments anymore. So you don't want to do that. Okay, so that's Dev and Ops. Now, I want to focus a little bit on an IT employee's value to their business. You know, as an IT engineer, we're hired to do something, whether it's develop code or maintain servers or deploy a server, switching and routing, or whatever the specific IT task is. Our value to the business is our ability to do that thing, whatever it is. And the path of least resistance typically is to do it manually. I need to check the logs on a server. So I'm going to log into the server and I'm going to like open the log file and search for something. Or I need to grant someone permissions to a server so they can log in and run a program on it. So I'm going to like SSH into my Linux server, and then I'm going to go to the sudoers file and I'm going to edit it and add that person permission. Like that is a simple way for me to do my job. That doesn't mean it's always the best way to do my job, particularly if that task is repetitive and you do it often. So this is where like I'm going to define DevOps for what it means to me. Just doing your job better, doing it faster, getting more changes done. Whether you're a developer or operations, you're going to be better at those specifications and skill sets that I went over earlier, because you're using these sort of ideas to do your job. I'm going to start with command line over graphical user interface. And this is kind of the bread and butter of IT, is to use command line, especially in the Linux world, to get things done. Microsoft kind of acknowledged this a while back and developed PowerShell, because all these sysadmins running Linux servers were saying how great it was that you could use Bash to do all sorts of things, but Microsoft was kind of lacking in that area. Now they have PowerShell. So the whole idea here is that if you're using a command to do something like create a new user, you can do it once and then you can save the command. It's a string of characters, it's text. You can dump it in a text file somewhere. And anytime you need to add a new user, you can just copy that text file you have and paste it in the command line and hit enter again. And if you do it regularly, and I mean like all the time, you can take that command and put it into a script, whatever your scripting language is of choice. And you can run that script. If you need to do a report on all the users who haven't logged in the past 30 days, like that's pretty useful. That's a couple of commands or maybe one really long one. You could put that into a script and say, I'm just going to run this script instead of doing all those commands. And when you're running commands and using your scripting language of choice, there's a very popular and I guess prolific change now to use software development kits and APIs to interface with infrastructure components. I saw this being a VMware admin. VMware used to have you log into their GUI. You were to make a new server. You like click through a bunch of buttons, and eventually you get a new server. You have to like go through a wizard, specify how many resources you want, what actual physical machine you want to build it on. And now they have an API and a software development kit where you install this little tool on your command line and you can run a command to build a server. And yeah, it's a long command. There's a lot of options involved, but if you build a server frequently, you can save it as a script and save all those commands and those options and make it very easy to quickly interface and build out a new server if you're using VMware. Well, Google and AWS and Microsoft have the exact same thing for their cloud services. Yes, you can log into Google Cloud and click some buttons and go through and do some things, but you can also do it all through command line, which is very useful. So to highlight, command line's better than clicking through and doing things with a mouse and a keyboard and a website. And when you're using a command line, you're going to make files. You're going to have a text file list of your commands, or you're going to make scripts. Or what config files, whatever it is you're using to manage your configuration or your code. Use Git to store those things. Don't stick them on a shared drive or your desktop or a folder somewhere in your home directory. Git is basically a requirement in IT these days for everyone. For those who don't know, Git is a way to upload files and share them in a team setting so that other people can see those files, make changes to them, and all the changes are tracked and stored. This is just basic version control, but it has become such a useful tool that if you were to apply for an IT job and they ask you if you know Git and you say, I've never really touched it, I think that is a big red flag for a lot of companies who are going to say, wow, I mean, even if you've been in school for 4 years and you've never touched Git, like that's very strange. We're looking for someone more in the industry or someone more in touch. So absolutely everyone should start using Git. Do it for your homework assignments, your classes, do it on your side projects you're doing. Definitely get involved and use GitHub and get familiar with how to use the tool. So let's say you're using command line to make all your changes, you're making new users, or deploying an artifact that a developer made, or creating artifacts using command line and code. You've got these text files or these various files of different languages, JSON or YAML, and you want to start codifying other things that you want to have. You want to make sure, like, you want to specify how to build that VMware server all the way through. Well, you could do it the hard way and basically interface with VMware directly, figure out all the API commands and go through all that. But there's these tools, which are collectively called configuration management, that have kind of already done that. Puppet, Ansible, Chef, Terraform does this as well. Essentially, they have already figured out how to interface with different resources like AWS or Google or VMware or Microsoft Cloud. And they've said that they've already figured that out. They've kind of created their own custom interface with it. And all you need to do is pull down their module that's publicly available and edit a config file in the format that they've selected. And once you edit that config file to add things like CPU, memory, and what sort of operating system you want, they will go build the server for you. And you don't have to figure out how to interface with those APIs directly. You can just use Puppet or Ansible to do that with you. So these tools are kind of critical for standardizing your config management, whether it's managing operating systems or servers or managing AWS buckets or databases or access control. it's very critical to have like a standard format for your configuration. And these tools both standardize your configuration so you don't have 7 different types of scripts that 7 different developers created. Everyone's using the same language. And most companies have picked one of these and gone in that direction. And once you use something, and I'll just stick with Puppet as an example. So say for my company that I just started, I wanted to use Puppet to deploy servers and then deploy my code to these servers and run my website. Well, if I used Puppet, I would have a bunch of config files sitting in GitHub that are written in Puppet code. And then I would pull down those config files and then deploy those to, say, Google Cloud if I wanted to, or AWS or whatever data center I'm using to build out my infrastructure and then deploy my code to those servers. Puppet would do all that for me, and I could do it with a couple of Puppet commands once I have it into a configuration file. But that's kind of normal. There's like not a lot of magic going on there. You're doing the same command every time you run that config, or you push that Puppet config. You're pulling down your Puppet code, and then you're saying, go deploy this stuff for me. And continuous integration basically says, hey, you're doing this the same way every time. Why don't you let us do that for you? And this is kind of a hot industry right now. And then there are a ton of tools right now, and everyone's trying to race to be the best at it, to get the business for it. Even GitHub recently came out with their own version of it, GitLab, because they want a piece of this market, because every company out there is trying to implement this to some degree right now. So continuous integration and delivery says, okay, you've got a GitHub repository with your configuration as code. You've got it written in Puppet. And now you want to, say, add a new server. You've got a Puppet config that says there's 10 servers, and now you want to log in and create a new one because there's a new application that needs a new server. Well, instead of editing your Puppet code and then deploying it manually, you just make a change to that GitHub repository, and these tools monitor your GitHub repository. And when they detect a change, they go out and then implement the change for you. And they can do more than just that, but they automatically deploy your changes. You can even stage your changes and say, I want to make this change at 10 p.m. tonight. And then you change your config files, you change it from 10 servers to 11. And then these tools will then go deploy that new server for you at 10 p.m. And you don't have to be logged in for it. They just handle it for you. And they do a lot of other great things with it, particularly error checking. And you can set up pipelines to alert people when changes happen and communicate whenever there's a problem with the deploy. And you can say that if there's an issue, just revert back to the previous version and undo whatever the change was. So there's a lot of tools and work being done here. But the important thing with these tools is it shifts your workload from, you're not actually deploying changes anymore, you're managing these tools. So instead of all your engineers working on deploying their changes and like logging into servers and deploying config files or running even Puppet locally or wherever they need to run it and deploy changes, all that work's gone. You're not doing that anymore. No one's doing that anymore. Instead, you're logging into your Jenkins server and saying, okay, let me make sure this job is configured correctly. Here's the Jenkins file for this job. It looks good. And if there's a problem, I'll sort it out. So essentially, your work is shifting from manually dealing with problems and new changes and new deployments and updating Java to making sure these tools are in place and that you update a few lines of code that says go from Java 6 to Java 10 or whatever version you need to be on. So this is just the end result in that any developer or operations guy now, they're not dealing with logging into servers and making changes. They're just editing config files, which are stored in a GitHub repo. And then whether they're using Terraform or some other tool, basically that tool is doing everything else for you. Once you merge that change into your GitHub repository, it will make those changes happen. And then you get to go make more changes. And I use the example of adding one server. And that's a fine example, but why not run 100 new servers? Like, that's the difference, is that I can build one server in the same time it takes me to build 100 now. Whereas if I'm doing this manually, like, that is simply not true. Even if I were to log into VMware and do some really fast shortcuts and know a bunch of secrets on using the interface, there's just no way you can get close to building 100 servers in the same time it takes you to build one. And this is what big companies are doing. They're scaling their infrastructure constantly. When you use cloud services, which most people are, you pay for what you use, or you actually pay for what you deploy. So if you deploy 100 servers and use 2 of them most of the time, well, then you're paying for 100 servers and just wasting your money. So a lot of companies want to be able to scale quickly. Maybe from midnight to 5 a.m., they only need 2 servers up, but from 5 a.m. to noon, they need 200, depending on their workload and how many users they have. Almost all endpoint customer facing mobile apps are this way. No one's using their banking app at 1 a.m. So the bank service doesn't need to have hundreds of VMs or containers or resources deployed at that point in time. They scale things down and they scale them back up when they do need them. So to recap, DevOps is both the skill sets of being a developer in operations and applying new tools, kind of automating that and being better at making those changes faster and doing them with less errors. And who's using DevOps? Like really everyone. And it all depends on how you define DevOps, but every company wants their IT department to be more efficient. This is like the Industrial Revolution. Everybody wants their company and their IT shop to be better. They want them to make changes faster. They want to go from a 12-man infrastructure team to having 3 or 4 really good people managing their entire data center. Even if they have to pay those people a lot more money, it's just a much better business venture to have 4 employees instead of 20 or 50. Especially if they're able to automate all this sort of infrastructure and development so they can get things done faster. When you have good DevOps practices, the developers are turning out artifacts every day. And some of them are for protection, some of them aren't, but they're constantly turning out changes. And the operations guys are saying, we need more changes. Like, we're getting a little slow down here. We've only made 20 deploys today. We want more things for us to deploy. If not, we're going to start experimenting with new technology, and you don't want us doing that. So the whole idea behind DevOps is to add more business value to businesses. And it doesn't matter if you've got 4 IT guys or 200. When we implement these practices, everything is going to become streamlined, standardized, and less error prone. You'll be doing production deploys faster and getting out those business requirements much faster. And ideally, both your developer and your operations employees are way happier in the end goal. So that's all I've got. I know I've been talking for a while. Are there any questions?
Yeah, we do have a few questions that are rolling in on our different sites, but let me ask a first question. You just made the comment, whether you have 4 or 200 IT staff, we have a lot of students, we have a lot of faculty staff that are watching, but we also have a lot of small businesses, IT folks that are within our West Kentucky region that are watching. So for a small, medium-size operation, how do you recommend, it'll certainly make them more efficient, but how would you recommend them getting started?
So I think the best route for any IT organization, whether big or small, is to figure out what is your business what is the value add that your IT shop has. What is the critical thing? Why do you hire these guys and girls to work for you? What do they do? Do they maintain your website? Do they make new changes? Is your entire business model based on IT, like maybe a website, or do they manage your marketing? Like what is the critical thing that IT does, the most value they add? When I worked for Cat Financial, it was maintaining their financial apps. They had financial applications that different people use to generate quotes and send out financial letters to customers, and that was the most important thing they had. Lifeway was a little bit different. It was a publishing company, and so there was a lot of in-house applications and also services that they sold to churches. And like our value add at Lifeway was to make sure that those websites that our customers used were up and running or easy to use. And Vanderbilt's a little bit different for me. The value add is maintaining these applications that are available and have users in the scientific research community that are using these tools to do research. So once you figure out what your business value is, what is stopping you from being better at it? What are your roadblocks? Can you not make changes fast enough? Are your developers taking 6 months to make what seems like an easy change? Have your infrastructure guys been trying to update your OSs for 6 months or a year? Like, have you been in a year-long operating system upgrade project? Like, that's a big issue. You're spending all this time and you're not getting a lot out of it. Like, why are these things taking so long? So figure out what your business value is, and then ask yourself and ask your IT guys, like, why are there roadblocks and what are they? And then tackle those roadblocks with these sort of technologies. Back out here. So make sure that if you're doing operating system upgrades and it's taking long, like figure out why, figure out what the issues are, standardize it, get rid of the errors. Make sure you're documenting. I mean, a lot of DevOps is really like documenting your changes as code. If you're editing config files on Linux servers a lot, make sure you have backups of those config files, stick them in GitHub, and make sure you can revert to those if you need to. And then work on, for a lot of companies, big and small, the problem is deploying changes. So look into using one of these tools to set up a pipeline that say, if I need to edit all 15 servers to restrict users or something, like maybe that should be a workflow on one of these continuous integration tools. Instead of taking an IT engineer 2 days to make that change, he can do it in 15 minutes. Now, it may take a week for someone to figure out how to set up this tool to do that job, but every time they have a request now, it can be done in 15 minutes instead of 2 days. So you're getting your value in implementing these tools by implementing them in things that you're going to be doing regularly. It could be a time sink to say, oh, we're going to set up like a Jenkins job to do something that we're only going to do once. Like, maybe that's not worth it. But if you're doing anything regularly, no matter big or small, try to standardize it and use these tools to get that done.
So for you, in what you're doing right now, what are the devices? Are you deploying applications to computers? Are you doing, IoT type devices? And how do you plan differently?
So we are Google Cloud specific. So everything I deploy, all my infrastructure is deployed to Google Cloud right now. And we're all over the place. We have Google App Engine, which is a little bit of a serverless technology where you're deploying those artifacts into the cloud. And then Google kind of just runs it. You tell it a few things and then Google handles it. We also have VMs, so traditional Red Hat Enterprise Linux machines. We have about 100 of those that are running. And then with those VMs, they have to be, we're FISMA moderate, which LBMC will tell you is a big deal. There's lots of security requirements around that. And so all those VMs have to be audited. We have to manage configs with it. Specifically, SE Linux and the user configuration has to be deployed and managed. And to make sure that all those VMs are, when they do get audited every year, are going to meet those requirements, we use Terraform to both deploy, and we use Ansible to say, here is using sudoers, which is Linux user management, as an example. Ansible talks to all of our Linux servers every day and says, here are the only people allowed to log into this Linux server. And if you see any other users that have been added to the server for some reason, even if they have very little permission, like all they can do is log in and then get an error that says they don't have permission, Ansible reports that back to us and says there was a problem and we cleaned it up for you, it's gone. So we use Ansible to manage configurations on servers and to do deploys. And we use Terraform to build out our deploys. And that's everything from like load balancers to firewall rules. When auditors come to us and say, show us your firewall rules, we can show them our Terraform code repo and say, here's what it's supposed to be. Here's everything we've said that we wanted to deploy. And if you look at GitHub, you can see who approved these changes and who made these changes. And then we can log into Google and actually look at their firewall config and say, and here's what's actually running. And if there's an issue where those two don't match, then there would be a really big issue, but there's not, because we only make changes using Terraform and it's all in code. We also deploy a lot of Google buckets, which is just a share drive or a storage unit in Google Cloud. A lot of our partner universities and research centers need to access data, and we use Google buckets and Google permissions to control those.
All right. Another question that came in is, what value do you place on testing? So where does that fit in this?
So That is a great question. I want to make sure I answer this as most correct as possible. If you're not testing, you're not a real IT shop, in my opinion. Like you're an amateur, right? Like this is the people who the equivalent would be building a car and never test driving it and making sure the engine works before you sell it to someone. Like you don't do that. You make sure that you can turn the key and that it works. And when you're buying a car, you want to do a test drive. You want to make sure the brakes work and the gas works. And it's just a great feel good before you pull the trigger and actually buy it. And the same thing for the car dealership. They want to make sure all their cars are going to start before they get someone sitting in them trying to use them. So everyone should be testing. Testing is almost more important than production. Like if your tests are bad, if you're deploying a new change, say you run a mobile app, a mobile game, and you're doing a big change, and you want to deploy this big change or adding a new level. Level 11 is coming out. There's only been 10 levels before. Well, if you don't test to make sure whenever you deploy level 11 that the rest of the game still works, and then you deploy it to production and your entire game craps out, even if it's only for a day or two, how many mobile users are never going to touch that game again? They're going to try to launch it that one day and it's going to be completely broke. And they're going to go, well, this is crap. There's like 15 million other games on the App Store. I don't need this one anymore. It's a serious loss to revenue. And the same thing applies for streaming services or online services. If you don't test and it's your fault that one of your deploys went bad and you broke something in production, you're losing users. And every user lost isn't just one, it's their friends that they're not also telling to use this service. It's your entire marketing campaign is now going downhill because of that one issue. So even if your product isn't great, it needs to work. And if it doesn't work, then you're in a really bad business model.
Yeah. Another question. Can you speak about the approach and value of infrastructure as a code? Are there any gotchas to this approach, in particular data stores?
So infrastructure as a code, a typical infrastructure would maybe be network or firewall or a server running like a Linux distribution. Infrastructure as code says that no one actually logs into that device and does anything to it. You don't manage your Cisco switches by like SSHing into them and running some commands and changing the config. Instead, you have a giant text file that is the config file to your Cisco switch or your Google switch or router. And when you want to make changes to it, you edit that text file and then you deploy that text file to your server. So I think you're asking, like, what are some issues with that model of having all your infrastructure as code and then deploying that code as a whole? And I think you mentioned data storage as the issue. Is that part of the question?
Yeah, a little bit more to that question. Any best practices or gotchas that can share about deploying databases using DevOps, in particular, any guidance for doing rollbacks? Maybe too specific, but throw it out there.
Yeah, so I guess infrastructure code as code is great for stateless applications, things like VMs and network switches and configurations like that. Stateful things that depend on being synced up, like databases that are maybe distributed or anything else that has some sort of, in Linux, there's an application called etcd that's used to basically share a configuration between 3 or 4 nodes. It's very common in container-based applications and other things. So anything that's doing that, where you have a stateful environment that is synced up, and then you try to change a portion of it, you could get into issues, particularly when there's different nodes. And the same thing if your database has data stored somewhere, like on a virtual drive in the cloud somewhere, but your database server environment gets changed, and then all of a sudden it loses some sort of ability to talk to that data because it's on different versions, or maybe the security token changed in the process of upgrading it. So anytime you have that sort of issue, I guess there's no way around it, dealing with those syncing issues. The main thing is that you have backups, that you both have backups and you've tested them to make sure they work. The worst thing you can do is have backups that you've never tested. And then when it comes time to restore, you're like, well, number one, I've never done this before. I don't know how to do a restore. And number two, who knows if it's going to work? Like, your backup is your emergency plan, and you need to make sure it works. It's the equivalent of like checking the sprinkler system every now and then to make sure that water comes out whenever there's a fire.
Right.
It's very important. You need to make sure that that when a fire starts, your sprinkler system is useful. Otherwise, you shouldn't have it. So I guess the answer to that is you need to make sure you have good backups, which are completely independent of infrastructure as code. Like, your backup infrastructure is a whole nother problem you need to solve.
Yeah, that's absolutely right. All right, so this next question, I got just a couple more questions, and then we'll shift gears again on topics. But I think I know what your answer is going to be, and I'm pretty sure there's somebody watching online with us that's going to have an answer that's not even one of the two options listed. Google Cloud and AWS, which is the best company for providing software as a service to its clients? And I would say there's somebody watching that might throw Azure in there as well. So what's your response to that one?
So number one, it depends on what the service is. Google created Kubernetes, and what Kubernetes is, I don't want to speak for the whole industry, but basically the go-to practice for deploying containers. And that's kind of where the industry's going towards deploying containers and managing application deploys, is using Kubernetes, and Google created it. So if you want to run containers in Kubernetes, maybe Google's your route. Amazon created serverless. Their serverless platform is far superior to Google's. If you want to not care at all about your runtime environment, you want to develop something in some proprietary language that only boots up whenever it needs to be called and used, maybe Amazon's the route to go. All of that said, Microsoft is best at taking your money. Amazon is second, and Google is going to be the open source-y. It's not fully open source, but it's more open source-y, and that they have some free services, they have free training. It's relatively cheap, and they don't have a lot of premium services. You can pay Microsoft to build out all of your virtual cloud data center for you if you want. Same thing with Amazon. You can hire them, and they will come in and they're going to build VMs for you. They're going to build your serverless stuff. They're going to talk to your developers and create workflows for them. They can even deploy those tools I showed earlier. They do all that for you. You ask Google to do that, they're going to say, well, here's a couple of links to some of our open source friends who have got some great tools. We think you should watch some YouTube videos on this and do it yourself and save yourself $500,000. So there's a different mindset to each tool. I do think AWS and Google are the two main competitors. If you're in a IT specific shop, if your goal is to provide really solid IT tooling or a website or an app or whatever it is, those are pretty much the two. There are a lot of companies that use Microsoft for other reasons. A lot of times it's because they get discounts. They're already using Outlook or email or whatever the issue is. So I think it depends on the company, but you should really, if I was managing a company, ask myself, what is our number one IT function, and which one of those three does it better?
Yep, that absolutely makes sense. All right, last question, and then we'll shift. There are a lot of students that either are watching right now or will be watching this, and it's not just our what used to be TSM, our cybersecurity network management students. It's computer science students. It's it's coders and network folks. So, what would you recommend for students to work towards if they want to get good at DevOps or get them ready to enter the workplace?
So there's a lot of tools and I guess training out there, like Amazon and Google and Microsoft all have something called like a DevOps practitioner certification. You can certainly work towards those. I am somewhere in the middle of getting my Google DevOps practitioner certification. I haven't been as good at keeping up with getting those. So some of those training classes are free. But for the students out there who are in college right now and going through classes and building out assignments and doing big projects, semester-long projects to have deliverables, why don't you look at using these tools? This is a great experience. Like, now's the time to figure out how GitHub works. And instead of just doing your homework assignment, your development practice on some local files in a folder in your documents directory, why not use GitHub for it? It'll take you 10 minutes to sort it out, and then you're going to be able to say you've got GitHub experience. And I think that's very valuable. So I guess don't hesitate to use these new tools. Certainly understand that like it may not be applicable. GitHub may not be useful in 10 years or 5 years, but right now it's very useful. It's the same thing with Jenkins or Puppet or Kubernetes or containers. Like there could be different technology, but what you really don't want to be is so far behind that you have no idea how to get to the future. That there's some new technology, or Amazon releases a new serverless squared function and you have no idea how to even start using a cloud, and they're already on like some sort of foreign version of it. So definitely dive in, do some crappy coding and figure out some really ugly ways to do things and then do it better in the future. But start using these tools and these practices now, even if it takes an extra 10 minutes.
Well, I appreciate that answer. And I should say, I'm pretty sure that there are at least some of our computer science, our programming faculty that now use GitHub for students to turn in their work. So that's how they are actually doing a lot of that now.
That's great.
Yeah.
That's fantastic to hear.
Yeah. Well, Jacob, thank you. You're always willing to give of your time, and we certainly appreciate it. As Dana Howard put in the chat, it's always great to see our alums come back and give back. So thank you very much. And I know there may be others that have some questions, and actually the person that was asking some of those specific questions, I might even connect you with him so that you all can discuss that a little more on the getting in the weeds, if you're okay with that.
Absolutely, I'd love to. Along that lines, if anyone watching, feel free to add me on LinkedIn.
Okay, perfect. Well, thank you very much.